the population of a city was 160,000. And once again, we don't know for sure if that's the initial or the final. We have to keep reading. And was increasing at, it was the initial, just when I started, just got there, right? Because it is increasing at a rate of 4.5, should say percent. I somehow did not put that there. So we know the initial is 160,000. My little I is 0.045. Now, how do I know it's not doubling or tripling? Because it's increasing by 0.045, and it doesn't say doubling, tripling, or half-life. So some people are like, I can't tell the difference. You have to narrow it down. Like if it gives you like a percent that isn't a doubling, tripling, or half-life, and it doesn't say the word compounded, it's an appreciation or depreciation question. Now here it says, write an equation to represent the population P of the city. So your final would be P. As a function of the number of years N since 2002. So N would be N. So they just want the formula. So we're going to have P equals 160,000. Are we adding or subtracting from 1? We're adding, because if it's above 1, it's growing, right? If it's between 0 and 1, it's decreasing by how much it is less than 1. So if I gave you the value in this bracket, and it was 0.7, is it increasing or decreasing?
Decreasing.
By how much?
30%.
30%. So a lot of people will tell me it's decreasing by 70%. No, it's not decreasing by 70%. It's how far you are away from 1 that's increasing or decreasing. So if it's 1.3, you're increasing by 30%. If it's 0.7, you're decreasing by 30%, because it's how far you are from 1. Okay? So if it's 30 above 1, you're increasing. If it's 30 below 1, you're decreasing by 30. Yeah, does that make sense? Most people don't script the percent if it's above 1, but a lot of people script the percent if it's below. They'll always give you that value as one of the options. So if it's like 0.6, they'll say decreasing by 60%. They'll have that as one of the options. It would be actually 40. They'll put that there to mess with you. All right. So we're increasing. So we get 1 plus 0.045 to the n. If you don't show the plus and put it together, they can see that you could do that. So as long as they can see that in one step you can do it, you don't have to show it. So if you can go right to this, that's totally fine. All right, now it wants you to determine the population in year 2005. So what's your n? It's 3. That's why this formula rocks. We don't have to like add 1 to it, like we had to do last year. So we have P equals, now some people are logging base 10 both sides. Why? It's all on one side. Just type it in, right? So what is your P equal? Should be more than 160. So it's 182,586. Some people will say 7. Where are we finding the extra 0.42 of a person? We're not. In the year 2002, there would be 182,586 whole people. Yeah.
So we don't round out, or it's always just whole number.
Because it's on whole people. It's like trying to fit, let's pretend we're fitting those people in a trailer. I don't know why we're doing that, but we're going to use that because I use it with cows. And we could fit 182,586.58 people into this building. We'll use a building. Trailer sounds a little nice. Into a building. Okay? I retract my statement. Could we just like kick them in and then now we have 7? No. Could we like cut their butts off and now we only have, no, we can't. So we can only fit that many whole people in. Yeah.
I have a question for you. It's nothing to do with math, so you might just pause.
And then this one says, if the population continues to grow at this rate, determine the number of years for the population to double. Now this throws people off because they read the word double and then they're like, oh, it's a doubling, tripling, half-life. No, the population is just doubling, right? So for it to the population to double, we would have 320,000 equals 160,000. 1.045 to the n. And what I tell you, the first thing you should do if you have final and initial given to you, divide it. Divide it and make it way smaller. Because right now I would have to make my y maximum be 320,000 if I'm going to use my calculator. That's insane. But if I divide the 160,000 over, I now have to make it be 2. So I get 2 equals 1.045 to the n. I can't make common base. I could y1, y2, but I'm going to practice log base 10 both sides, which I can just write as log 2. I don't have to write the base 10. Log 1.045 to the n, and then the n drops in front using power rule, which we haven't even learned yet, but we're super troopers, so we're good. We get log base 2, or log base 10 of 2 equals n log 1.045. And divide by log 2. And n equals 15.7. Checking it out. Would have actually been 15.8 anyways. Would have been 15.7. So good. All right. The number of fish in a lake is decreasing by 5%. Stop it. Stop knocking my coffin. Let's just try and clear my throat. Slow. Need help. Okay. Write an equation to represent the number of fish in T years using NO to represent the initial population and NT to represent final. So we're going to get N of T equals NO. And then we're going to get what in this bracket? 1 minus 0.05 to the T. So we actually have N of T equals NO 0.95 to the T. All right. Here we have, if there were 2,500 fish present in January 2000, how many would be present in January 2005? So it's giving us the initial, and it wants the final. So we do N of, that's a 5. It's not. I got it. N of 5 equals 2,500, 0.95 to the 5. And so we have 0.95 to the 5. And you get 1,934 fish. And if this was diploma or a unit test or whatever, you would say, in January 2005, one would expect that there would be 1,934 fish present. Bad place. Okay. How many year? Good. So, to the nearest 10th, would it take for the fish population to reduce to half of the number in January 2000? So half the number means final is 1,250. Initial is 2,500. Now remember, your final should be smaller than your initial if it is decreasing. Your final should be larger than your initial if it is increasing. So even if you don't know which is final or initial, if it's increasing, it should be bigger. Put the bigger one first, right? If it's decreasing, make the smaller one first. So we get 0.95 to the n. Divide by the, if you have final and initial, divide it over first. And we're going to get 1/2 equals 0.95 to the n, which you could use your calculator for logs both sides. So we get log of 0.5 equals log 0.95 to the n, and then using power rule, n can drop in front. So we get log 0.5 equals n log 0.95. And then divide by log 0.95. And then it says to the nearest tenth. So you get 13.5. 13.5 years if they don't resell. My writing looks like Etch-a-Sketch on this board. It drives me crazy. Okay, so we did all those. Then we're moving on to these ones. Is this the first one, or was there one before this? I can't remember.
I think that's the first one.
Okay. So here we have a radioactive isotope. We're hoping that the radioactive isotope is halving and not doubling or tripling, because that's insane, right? Radioactive things should not be getting bigger. We're hoping that they're depleting. We're hoping that they're decreasing. I don't know, but we don't want them to grow. So when people put 2 or 3 in there, it scares me. Bacteria could decay or could grow, depending on, like, if you put medicine into a bacteria petri dish, it would decay, right? Or if they just put it in a petri dish and let it go, it would grow. So that's one that could go both ways, but most often it grows. So here we have a radioactive isotope has a half-life of 7 years. So I know that R is a half. And is this T or P? P, because every 7 years it's halving, right? So this actually has 7 years, is quite some time. How much of the isotope must be initially present to decay to 60 grams in 14 years? What is with me and not putting S's? Years. All right. So we fill it in, we get final equals 60, initial equals I, R is a half or 0.5 to the T over P, which is 14 over 7. So I get 60 equals I to the 0.5 to the 2. Now some people want to log base 10 both sides. There is no point to log base 10 both sides unless we're trying to get that exponent to go down. That's the reason why you log base 10. You log base 10 is if you don't know the exponent, so that the exponent can pop in front and you can divide and you get answers, right? That's the only time you log base 10. So I know the exponents. So I am not going to log base 10, I'm just going to math. I'm going to math it up. That is what I'm going to do. So this I is multiplied by this, so I'm going to divide by that. So we get 60 divided by 0.5 squared, and it's 240. 240 grams. Okay, the next one says a material has an initial mass of 50 grams. And by grams, I mean milligrams. And a half-life of 20 minutes. Is that P or T? It's P. Remember, this is also another way to know if it's P. If it follows right after half-life or doubling or tripling, it's P. If half-life or doubling or tripling is in the question, they're looking for P. So if in your last statement they're saying what is the half-life, what is the doubling, what is the tripling time, they're looking for P. If it's stated before, they gave you P. So P is 20 minutes. Determine the mass after 35 minutes. So they gave me T. Also, T is really easy to find if you know you already have P or you're looking for P. Then you know the other one is T. I find P is easier actually to figure out because it's repeating the period. Okay, so what are they asking me to find? Final, not any type of exponent. So I'm not going to have to log anything, okay? So final equals initial, which is 50, half the T over P, which is 35 over 20, and then we just type it in. And you get 14.9 milligrams. or 15 milligrams if you went with that, because honestly, it doesn't say what to round to. So if you picked 15 or you picked 14.9 or you picked 14.87, you're right. All right. This one says a culture starts with 3,000 bacteria. Bacteria often grows, so it's probably a doubling or tripling. After 3 hours, it's estimated the count is 48,000 bacteria. So this is T. It's time to reach final. If you don't know if that is T, if the word half-life doubling or tripling is in the question, that is what they're looking for. They're looking for P, right? So that's always my giveaway. It says, what is the doubling period? So I know R is 2, and we're looking for P. So my final is 48,000. My initial is 3,000, which makes sense because it's doubling, so it's getting bigger. And I'm going to get 3 over P. And now Peter's going to be super happy, not because there's a P up there, but because he's going to get to log both sides, because we need an exponent down. So I divide, or we could do what in this one? I want to use common base.
You betrayed us.
You know what? Common base I like better anyways if I have the option. So that's what I would have done too. So 16 is 2 to the 4 equals 2 to the 3 over P. So 4 equals 3 over P. P equals 3 over 4. Or 0.75 hours. So this thing repeats itself. It doubles every 0.75 hours. Okay, last word problem is compound interest. Now, how do you know it's a compound interest question? Because there's the word compound is in it. If the word compound is in it, it's a compound interest question. Okay? Now we're going to talk about compound interest. So if you're putting money into a bank and you want to make money, you're hoping that it is a compounding situation. Because compounding, what happens as opposed to simple interest, compound interest is it takes your amount of money and it takes the interest rate and amount you made and puts it in, and then the next month you're making money off the interest. So for example, if an investment compounds monthly, at the end of the first month, it'll take the interest you made and it'll put it in with your principal, your initial amount. And the next month, you're now making money off of what you put in plus the interest. You're making interest off the interest and the money made. So if you are actually putting money into a bank, you want it to compound more. So you'd actually take compounding daily if they gave it to you, because it's going to take the interest, it's going to put it in, you're making interest off the interest faster, right? If it compounds yearly, just at the end of the year they take the interest and they put it in, and you only start making interest after a year, not after a month, not after a day. If you are paying for something, like a mortgage, you want it to compound less, because you want it to take the interest that it's making and not put it in for a while. Because if not, you're paying interest off the interest that you've had to put in too. So mortgages are only allowed to compound semi-annually, which is twice a year. So that's better than 365 or 12, right? So when you are putting money in, you want it to compound faster because you want to make interest off your interest faster. And if you're paying off something, you're hoping for the compound period to be like never. You want simple interest where you'll never simple interest never makes interest off your interest. Simple interest, you just make money off your principal, that's it, and at the end they just take all the interest and give it to you.
That's interesting.
Yeah. So annually compounds how many times a year? Once. So my CP, my compounding period, would be once. That's what CP stands for. And semi-annually is 2 times a year. Quarterly, how many quarters are there in a year? 4, just like seasons. And then monthly is? And then days, they often don't do, and if they do days, they'll say that it is not a leap year for all the people like you guys who will be like, is it a leap year? Is it not a leap year? It's 366 as well. All right. These all mean the same thing. You can write down what all the things are again if you want to, but they mean the same. So it's final, finial, I don't know how to spell it. Final amount, initial, interest. It has to be in decimal form per usual. This is number of years. and this is compounding. Now, this will always be an appreciation formula. There will always be a plus, 1 plus, because you're always increasing. Whether you're making it's a loan, you can pay it down, but we're not doing that, thank goodness, because that's way more work. So it's always 1 plus. Now the catch here is, if they give you the formula, it often looks like this. Accumulated amount equals principal, 1 plus I to the n. This is what they often give. They don't give the compounding period part. Okay? And it doesn't matter what variables they give you, it all means the same thing. Final comes first, initial comes next, 1 plus your interest rate to the end, right? It doesn't matter what variables they give. What you have to remember to do is divide by the compounding periods if it's the interest rate, and multiply by the compounding periods on the years. Because you want to have the interest rate that you're making. So if in a year you're making 12% and it's monthly compounding period, that means every month you're only making 1%, right? Does that make sense? So if in a year you're making 12%, every month you're only making 1%. So that's why you have to take your interest rate and divide it by the compounding periods, because it's the interest rate per compounding section. And then n you have to times by compounding periods, because if it compounds 12 times a year and it's in for 3 years, that's 36 compounding periods. So you're going to have to always, even though they show it like this, your I has to be divided by compounding periods, because you have to find the interest rate per compounding period. And your n has to multiply by compounding periods, because it's all the compounding periods that exist. Okay? Every single time. So, let's go here. Isla invests $500. Thanks, board. I love you so much. So great. $500. Is that initial or final? She's putting it in. In an account paying 6%, what's that? So that's my I equals 0.06, but I always have to remember to divide it by something. Compounded, that's how I know it's a compound interest formula. Compounded semi-annually. So my CP is 2. So my I is going to be divided by 2. So my I is actually 0.03. Do you agree? Determine the value of the investment after 5 years. So they're making me find the final. And what is my N actually? 5, but times 2. So I actually have 10 compounding periods, right? In this investment of over the 5 years, it's going to compound 10 times, right? And every time it compounds, the interest rate is 0.03. Do we agree? So my final equals my initial, which is 500. And then I get 1 plus 0.03, because I need the interest rate per compounding period. And then the number of compounding periods, which is 10. So my final is 500, 1.03 to the 10. And I get 671 96. So if they asked you how much interest did you make, you wouldn't tell me 671.96. What would you tell me? How much interest did you make?
171.96.
Yeah, you went in the bank with 500. You walked out with 671.96. You still went in with the 500, right? So the interest you made was 171.96. Because sometimes they don't actually ask for the final, they ask for how much interest you made. Now here it says, how long will it take for the investment to double? So I need my final to be 1,000, my initial to be 500, and it's still 1.03 to the... Now, I need an n. I can't just put n here. What would it actually be? N times 2. Because n is the number of years, right? Not the number of compounding periods. if they ask for the number of compounding periods, you would just have to take your n and times it by whatever compounding is. So I always divide my initial over first if I have my final and my initial. So I get 2 equals 1.03 to the 2n. Now I told you can y1, y2 this in your calculator, or we need the exponent to pop down. We can't make common base, so we log both sides. Then the exponent can drop in front using power rule of logs, which is on your formula sheet. So I get log 2, and you should really put whatever's beside your log in brackets, just so you know. Because whenever you press log, it's going to open a bracket. And it's going to help for transformation. 2n log. And now I just need n by itself. So what am I actually going to divide by? 2 log 1.03. These are all multiplied, right? Now make sure, if you're putting this in your calculator and you don't have the fraction button, which I would always use my fraction button, you are going to, guys, you're going to have to put this, if you don't use the fraction button, you're going to have to put your denominator in brackets. Why is that? Yeah.
Because it would divide the log 2 by 2, then multiply it before it would actually do the whole.
Exactly. Your calculator will always do order of operations unless you force it to do otherwise. So if you don't put brackets on the bottom, or you don't do the fraction button, right, which I will always do the fraction button unless I don't have that calculator, you have to go log 2 divided by the bottom in brackets, or it will go log 2 divided by 2 and take that answer and multiply it by that, which is not at all what you want it to do. Okay? And I get 11.7, where did I say 12? 12 years. So it takes 12 years to double, but what if it asks you for how many compounding periods to double? What would you do? Yeah.
Would you divide that number by, no, multiply that number by 2?
Right, but we have to multiply what number by 2?
The 11, what?
Yes, because we can only round to the very last step, correct? So if I have 11.72, blah, 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 I'm going to times that by 2, which gets me 23.4, which is still 24. Don't get me wrong, it worked out. But what happens if you have 11.7 something, and you, well, because you have to still do 24. Why would you still have to do 23.4 if it's 23.444? It wouldn't reach double if you rounded it down. If you walked out of the bank at 23 compounding periods, would you actually have double? No, so you'd have to wait till 24. You'd have more than double, but at least you could buy the car. If you needed $1,000 to buy something, that's what you have to think. Could I walk out at 23 compounding periods? No, the person would be like, come back at 24 compounding periods. Okay. So always, always, always only round at the end. It ended up working out to the same thing, but that's because it's semi-annually. It's only twice. If you have to do it monthly, you won't work out to the same compounding periods if you take it rounded to years and then multiply by compounding periods. It's going to give you too many. So always, 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 if it asks for compounding periods, take your answer, times it by whatever the compounding period is, and then do your rounding. So it'll be 12 years. Okay, example 2, example 3, and then I don't care about that. Example 2 and 3, start working on those right now. And then we are going to move to graphs. Exponential graphs quickly. So if we look at y equals 2 to the x as an exponential graph, if I fill in -3 in for that, my y would be 2 to the -3, which would actually be 1/8. Because 2 to the 3 is 8, and it would just drop to the bottom, so it's 1/8. And then this one would be 2 to the -2, which is 1/4. This would be 2 to the -1, which is 1/2. because it just drops it to the bottom and makes it positive. This would be 2 to the 0. What's anything to the power of 0? 1. Awesome, board. Thank you. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3, 8. And 2 to the 4, 16. So this graph is actually doubling, right? Its R value is a 2. So it's doubling. So it's increasing. We agree? So let's sketch some coordinates. So we have -3 and 1/8. So just close to the x-axis. -2 1/4, still close to the x-axis. But oh my gosh, board, work with me, whatever, really large point. -1 1/2, 0 and 1, 1 and 2, 2 and 4, 3 and 8, and then I'm done. Now, this graph has absolutely no numbers written on it. We agree? So if that's the case, we have to write what the heck our scale is, or we're just assuming that people know. So we have an x scale of 1, and this one has a y scale of 1. It just means that every tick is worth 1. So what's happening is we're connecting these, and it's heading upwards. Also, if I did -4, it would be 2 to the -4, which would be 1/16. It's just getting really, 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 really close to the x-axis, but not touching it, right? So this is going to run along the x-axis. And we actually have a horizontal asymptote on the x-axis. What is the equation of the x-axis? Y equals 0. All horizontal lines are all y equals lines. So this would have a horizontal asymptote. And it's horizontal because it's horizontal. So asymptotes are like the electric fence where you can like go across, but you can't get closer. You get closer and closer and closer to it, but you can never touch it. I was pretending it's like a cow. The cow is walking along and trying to eat the feed on this side, but there's an electric fence, so it just walks along it for life. Okay? So that's an exponentially increasing function, right? If it was decreasing, so say it was a half instead, it would be like this. Ooh, that's an aggressively large. So say it was a half. If I put in -3, it would be 1/2 to the -3, which is actually 8. Do you agree? So this would be at, instead of 1/8, it would be at 8. And instead of 1/4, it would be at 4. And instead of 1/2, it would be at 2. 0 and 1 stays. This would be at half. This would be at 1/4. This would be at 1/3. Wait a second. It's decreasing, but it's also completely reflected in the y-axis, isn't it? How the heck is that possible?
Half is 2 to the -1?
Yes.
2 to the -3.
We can only compare graphs for transformations if they have the same base. So our graphs that we've just compared is 2 to the x, and the other one is 1/2 to the x. But 1/2 is actually the same as saying 2 to the -1 to the x, which we can write as 2 to the -x. So the only difference between this graph and this graph is a negative in front of the x. And what's a negative in front of the x cause? A reflection in the y-axis. Okay? So what's the domain of either of these? The blue or the red? Or blue or red? Blue or green? Yeah. XER. Oh, come on. Lord. So x such that x is an element of the reals in set notation. In interval notation, negative infinity to positive infinity. And what is my range? Yeah.
In interval notation to be 0 with a round bracket to positive.
Be 0 with a round bracket to positive infinity because it can't equal 0. It's everything above 0. So in set notation, we'd say y such that y is greater than 0. Y is now in the reals. And both of these have a horizontal asymptote. Where the graph can't go on the x-axis, which is y equals 0. It has no x-intercepts, because that's where the asymptote is. And the y-intercept is a coordinate, and it is at 0, 1. What's the only thing that what could cause us to have an x-intercept?
Vertical shift.
Vertical translation, taking that whole graph and shoving it downwards, right? It would cause it to have an x-intercept. So actually your vertical translation is your asymptote. So because the only thing that can move that dashed line, is a vertical translation. Horizontal translation isn't going to move it. Horizontal stretch isn't going to move it. Vertical stretch isn't going to move it. Can't make it fatter. Reflection isn't going to move it. Graph will just go on one side or the other. It'll change your range. Your asymptote is your vertical translation. I'm going to write that at the very top of this in bold with some stars, if my board lets me. Setting at -3.
It's no longer very cold outside.
It's nice. It's actually not even brisk anymore. That's just great as long as there's no wind, you know. The rest we're doing tomorrow.